Welcome all. Good afternoon, and welcome to today's session hosted by Numerical Analytics Instrument Private Limited. So today's session is somewhat a little bit interesting. So because we are going to see a couple of things in function which you cannot do in a press to test mode, and we will see how we can use our creative way, and we will try to do in the press to test mode. So first we will start with the inverse of function. I think that's the biggest point that we cannot do in a press to test mode. So let me just take you to directly to my calculator screen, and let's see how we can do an inverse function, whether it is a press to test mode or not in a press to test mode. So first we will see when our calculator is not into press to test mode and how we can do inverse graphing. So this is my home screen. I'll add a new document here. So let me just add a new document. So I'll add a calculator page and I'll define usual function. Okay, I'll do the usual things. Okay, I'll define a function fx. Let's say a simple function x squared. And I know because this x squared is not one function. So I'll define a domain for it. Let's say x lesser than equal to 0. I'll hit enter and it says okay. So this is a usual way of defining a function. And then I'll go to my graph and I'll say, okay, no problem. I'll draw fx. Fx will be visible. I can see it is a one function. I'll go to my menu. I'll go to graph entry. I know the relation, the inverse is a relation function. It will be drawn as a relation function. So I'll go to relation. I'll say, okay, x equals f of y. Hit enter. It gives me the inverse of the function. So let me just change the color so that you can see clearly. So x equals to fy is my relation function. I can go to menu. I can trace my function. I can trace. I can use trace option. I can trace the function. I can even trace the relation. I can do a lot of things. But ma'am, can we draw a table of this relation?
I wonder what it would be. Let us check. Let us check.
Can we draw a table?
Table of values. You mean table of values,
right?
Yeah,
right.
So
we know that we can draw a table of values for the function, but I don't know whether we can draw for the relation. Let us check. If I go to menu, if I say table and if I say split screen table, it gives me the table for fx, ma'am. Let me go left or right to check whether I can get. No, we don't get the table for relation, but there is something called relation one. Let me hit enter. Nothing happening. So I cannot get the values here in the table for the relation. Okay, no problem. No problem. Let me just remove my table. So this is a way by which you can draw an inverse of a function when you are not in a press to test mode.
Yeah, Hassan, please clarify that. Is this a press to test mode?
This is not a press to test mode. This is a usual mode of your calculator. Okay. We are not under a press to test mode. We are able to draw a relation. So how I made the relation graph? Let me just delete this and let me show you again. I'm not in a press to test mode. So I'll go to menu. I'll go to graph entry and edit. I'll go to relation. I'll say, okay, x equals f of y.
Yeah, that's the definition of an inverse.
Yes. Okay. I'll hit enter. It gives me the graph. It gives me the relation, not the graph. I can change the color to red so that I can see visibly. There is one more way of doing this. This is one more way of doing this. Let me add a new graph page. I'll say, okay, f of x is here. And let me show you one other way in a usual mode, okay, not in a press to test mode. You can right click. You can see there is an option number 5 called text. Okay. Yeah. You can select this text and you can write the relation here itself. F equals to f of y. Hit enter, nothing will happen. Okay. But as soon as you drag this to any of the axes, you can see the graph. Okay. You can see the relation. Okay. So this will be your relation. Let me just change the color to something blue. So this is relation. Red one is my function. but I cannot see. I can trace.
And Hassan, I think if teachers were to demonstrate this to students, they could change the f of x to any other and it would still hold true.
Exactly.
Right? Yeah,
exactly.
yeah.
Let's say, let me just change the function. Okay. Let me just change the values. So if I change the function, let's say something complex, something like sine inverse x squared minus 1 divided by x squared something plus 1, and I'll say, okay, not for lesser than but greater than equal to 0. Okay, can we do that? Let's do. Yeah, we can be able to see the inverse as well as the function. So fx,
and drawing the y equals x line may be a little more illustrative of the
exactly.
Yeah.
So we can do that also. So let me just go to menu and go to graph and the function. I can say, okay, no issues, y equals to x. It will show you the line. Okay, y equals to x, and we can say it's a mirror image about the y equals to x line.
Yeah.
Okay, we can be able to do this, but we cannot be able to draw the table of the point of the values, but we can trace. So there is a limitation. There is a limitation even in a usual mode that you cannot draw the table. Okay, forget about the making of inverse. You cannot be able to draw table. Now what if I'm in a press to test mode? Let me take you to my handheld, which is under a press to test mode. You can see it is under a exam mode, and let me just open a new calculator page and let me define a function fx. Okay, let me define a function fx, a simple one, x squared, and let me define the domain so that it will become a 1 so x, let's say greater than equal to 0 this time. Okay, so my function is defined. So now let me go to my graph page. I will add a graph page. I will draw a function. Okay, from here I'll draw fx function. Fx function will be visible here. Okay, now I want to draw the inverse of this function under a press to test mode. Now I'm not in a normal mode. I'm in a exam mode. I want to draw the inverse and I want to trace that function. I want to draw the table of the values and everything I want to do. So to draw the inverse of the function, what I need to do, I need to go into the relation. Okay, so what I'll do, I'll go to menu. I'll do the usual thing. Okay, I'll do the usual thing. I'll select graph entry and edit. I'll go to relation. Here, what I'll do, I'll say x equals f of y. This is how we have got the inverse of the graph.
Yeah.
Now. Let us see
now. What's different now?
Enter. Oh, some error is coming, says test restriction. This functionality is restricted in test mode. So forget about making a graph. You cannot forget about making a table. You cannot even draw a.
So Hassan, either of those two methods will not work in the press to test mode. Is that correct?
Let us check. No issues. So first method is we cannot do that. Let us do control menu. Let us go to option number 5, text. We have checked in a normal mode that we can also draw inverse using the text. I'll say, okay, x equals f of y. Is it y? Yeah. Hit enter. Now let us drag this. So I'll select this. I'll drag. Oh, the same error is coming like test restriction. This functionality is restricted in test mode. So how we can do inverse graphing under a press to test mode?
Yeah.
Forget about making a table or tracing a graph. We cannot be able to draw inverse in a press to test mode. So there is a way. Hold on. Let me just take you to my presentation and let me go to the definition of the inverse of function. What the inverse of function definition? What is a definition or a property defines? It says something f inverse of x is equals to x. If we can
the composition.
If we look closely, it says that if you put the value of image inside the function, it should give you the pre-image. Isn't it the inverse function says like give the image value, it should give you the pre-image.
Yeah, that's correct.
So if I use this definition of putting image and getting pre-image
okay.
into the function inside the press to test mode graphing, shouldn't I get the result?
Makes sense. Makes sense.
Let me go back to my calculators page. I'm in a normal mode. See, I'm in a normal mode. Okay. I'll add a new problem. What I'll do, I'll use this definition. Okay. I'll use this definition and I try to create an inverse function.
Okay.
And that should work. According to the definition, it should work. Okay. So what I'll do, I'll quickly copy this. I won't waste any time writing this. I'll quickly copy and paste this into a new problem that you can do. Okay. So this graphing calculator gives you the opportunity to copy and paste. Hit enter, it says done. So now my definition was, if you put the image value, it should give you the pre-image. So what I'll do, I'll say, okay, I'll define a new function gx and I'll say this gx is my inverse. So not to confuse you, what I'll say, okay, f inverse fi. Okay, it won't confuse you. Fi means functions inverse. Okay, functions inverse. What I'll do, I'll define this definition inside and solve. Inside and solve. What I'll do, I'll say, okay, f of y, for what value of image, it gives me the pre-image. Okay, now my variable is y.
So you're defining it as a function now.
I'm defining it as a function. I'm saying, okay, for what value of image, it gives me the pre-image. And my variable is the image, y.
And that is for all values of image.
All values of image.
Okay. That is why that comma y is so important there.
Comma y is very important. So variable should be the image for all the value of range. If I'm not wrong, range.
Yeah.
If I hit enter, it says define. What happens? Okay, let's see in the graph. Let's see in the graph. Okay, I'm saying f of x. F of x is given to me. This is usual graph. Okay, a usual function. Let me draw a line y equals to x. Y equals to x.
Yeah, that will help.
That will help. So let me draw.
Hassan, we could have also done f inverse of fi. We can try that later on.
Later on we can see that.
Yeah.
But let me draw inverse with a usual method. Okay, I'm doing for a usual method. Okay, x equals f of y. This is we do when we are not in a press to test mode. Okay, I'm drawing this just to show you that what I'm doing is right. Okay, so what I'll do, I'll take it to any of the here you can see. I'll give this some different color. Let's say a red, not a red one, a green one. Okay, so this is my usual way of doing inverse graphing. X equals to f of y. But my inverse graph, what I have defined on the basis of the property given to me in the inverse, like f of y should give me x, is fi x. So let me go back. Let me hit tab and let me draw the graph of f of inverse of x. Should it give me the answer?
I think so.
Anyone? Participants?
Yeah. Anybody here?
Anybody here? Should it give me the result?
What do you expect? Okay.
Yes. Somebody says, I think it should. Yes. John said. Thank you, John. So let's hit enter. Okay. Ta-da. Oh yeah. The black one. You can move it around. You can play. So the black
this also kind of reinforces the domain and the range kind of concept in the students. It clarifies that for the student.
Exactly. So let me go to my relation plot and let me just hide that. So now you can see clearly the black one, the black colored graph is my inverse function. Okay, this inverse function.
Sometimes
So,
students,
is there any way to check directly from here by putting some values, and can we check?
yeah, we can use the f of inverse to check if we get y equals x.
Let's say f of 2, it gives
Yeah.
me 0.662.
Okay, you're checking
F
for
of
values.
inverse of this should give me 2.
Yeah.
Isn't it glorious? Like you can draw.
Yes.
Now the best part, if you press Control T to draw the table, let me put table in another
Wow.
page.
So this is a cherry on the top. I would say it is a cherry on the top of the cake, because we can graph it as well as the table of values. I see the table of values right now.
You can change the, you can even change the table settings. You can change the table settings. You can change the steps. Let's say 0.05. You can change this, and you will get the more result you can get. Okay.
Because now it is treating it as a function.
Yes, because it is treating it as a function. Now, many possibilities has been open for you.
Yeah. Yeah.
Because we are treating inverse, not relation, inverse function as function here.
Yeah.
We are
Maybe
not treating,
I can show this. I can apply this to the question that Jalaj and John were working on last time. And after you are done, I will just show. So you can complete.
I want to show one more thing, like how we can use this possibility of defining an inverse function in few of question. Like I will show one question. Let's see how we can use this possibility. Like I have one question here. So this is I have done. Like you can draw the graph. You can change the table settings, the steps to see more values. I have one question here which says the D part, especially the D part. I have one function fx as 2x plus 5. I have one function gx as 8 minus x by 2. And I have one question part D. In this question part D, which says for what value of x, the f of g inverse x is 9. So I can use the possibility of making inverse, defining an inverse function, and try to find the value of f of g inverse x equals to 9. At what value of x it gives me 9? So let me just do that. So let me add a new. Oh, but I didn't show you. In the press to test mode. Okay, but the same step will go into press to test mode. Okay, the same steps will go into the press to test mode. So if you are under a press to test mode, these are the steps that you can, for that you can be able to define an inverse function, and you can plot the function. You can find the
Hassan, do you want to do the current question in press to test mode on your calculator?
Oh yeah.
Yeah.
So let me do in a calculator. Okay, so because I'm in a press to test mode, so it will be more understandable. Okay, so I think everyone can see my screen. So okay, I'll add a new problem. So I'll say, okay, I'm in a calculator. I quickly define my function. My first function is 2x plus 5. It's a very basic question, nothing much. You can even solve it by hand, but let me show you the capability of calculator, that you can define inverse function here. So let me just define another function gx, which is a relation function, that is 8 minus x divided by 2 over 2. So I have defined two functions. So let me define now g inverse of x, because in my question, the fourth part, it only says f of g inverse of x. I can find f inverse of x also, but let me define just f of g inverse of x, because there is a time limit. So what I'll do, I'll define this as gi. Okay, I'll define as gi because it will be more understandable for me, I think for student as well. So I'll go to algebra, I'll select this option and solve, and I'll say, okay, g of y should give me x. Okay, for what value of y? All right. So while I'm saying this, I'm revising my concepts. Okay, while I'm saying this, for what value of y gives me x. So I'm revising as well. So if I hit enter, it gives me, it says done. All right. So now I wanted to find f of g inverse of x. So it's a composite now. It's a composite function. So I'll go back to my handle. I'll say, okay, no issues. I'll go to 3. I'll select and solve. I'll say g of, sorry, not g, should be f of
f of gi.
gi. Okay, it will become bold. X gives you 9. For what value of x? Okay, hit enter. It gives you 3. It gives you 3.
Awesome.
Okay.
Awesome.
So this is the way by which you can define an inverse function, and you can find, you can now, all the possibilities now open. You can do many things.
True. Yeah.
So let us go to Ms. Shazam ma'am, who will show you in actual IBDP question how you can use this possibility to solve it.
Right.
Over to you, ma'am.
I'm going to share right now. Okay, and this was, I just want to remind, I think we have got some of our participants who are regular here, and you might remember the question, this question here. And even if you don't, it's all right, because we are going to go through it. All right, this was one question where there was a sketching of the inverse. And in my experience, students do kind of fumble on this question, because, you know, the reflection around y equals x is not very clear to them. They're not specially, you know, developed in some cases. So that's why. And then there is another question. It says solve for f inverse of x equals 1. And then here is a composite function. So I'm going to try and apply what Hassan has just shown to us to this question. And if there are questions, please do not hesitate to ask us. All right. So this is the function. All right. This was the function here. Now so here is the function, right? And these are the answers so that we can check back the answers. So you got the function. And now I want to draw the inverse. So I've defined it. I'm going to open another page, right? And graphing. And let me graph this function, because we've got to graph it as well. So I'm going to just go up, and it's a graph. So I'm going to press enter, right? And now I am going, and I will first kind of define. So I'm going to call it I, just as an inverse of x. And I'm going to define it as Hassan explained to us, you know, because it's kind of a solving. You're solving for every value of y. So that is why we are going to use and solve f of y equals x, because you're solving, that is y equals x. And I want to do so at every value of y, right? And I am going to kind of, now that I'm just going to define this right now, and I'm done, right? So when I go back here, right? Now, the question here did say, so now this is not a one-to-one function. So there was a bit of extra information here. So now it says the domain of f is now restricted from 0 to a. So what I've got to do here, I've got to obviously kind of find, so 0 to a. So here we've got to look at the minimum here for the value, and I am going to analyze the function, and or, you know, trace or analyze the function. Trace, I can do a couple of things. So I'm just going to use trace. And here I am using, okay, so I get the y-intercept. So 0 from 0 onwards. So I'm going to press enter. And now I'm going to move on until a point that I get a minimum. So I'm reiterating Jalaj's you know, explanation last time about how to use this minimum. And I'm going to press enter, because these are the values that I'm interested in. And I'm going to escape. And now I've defined it. So here, so I have to define the inverse from negative 5.4 to 4. So I can, so alternatively, I could also store the value as A and B. because here there is an extension, just to be more accurate. But I think 3 significant figures is accurate enough for sketching the graph. And I will go here and I've defined it as I of x. So I'm going to do I of x, right? And I am going to restrict it from negative 5.4. So negative 5.14 to x and to 4. Enter. So this is your inverse, right? So so students really have a good understanding. Now I could have done f of, I'm just going to go ahead and kind of where the teacher is head right now, explaining to the students, and I'm going to say f of so not here, but I'm going to just graph maybe here, and I'm going to go as f1 or f of I of x, and I'm going to press enter. And here I've got the y equals x line. So it is kind of a good, of course, I could have defined I could have restricted the original function to get a better understanding, but and I can still do that. So I can go up here and I can kind of just to make it a little more visible or clearer, I can kind of restrict the function from 0 to 1.67. So go 0, restrict the function between, right? So this is x. Again, define the other bound here, which is 1.67, and press enter. So, it just becomes a little more kind of visually appealing, and right. So this was one part, but there are further parts. So this is just what Hassan had explained to us, and there are quite a few questions that demand that the students draw the inverse, but not that, but do other further questions to it, and then we've got to solve. Well, of course, you could have found f of 1. That is another way, but here I can just graph 1. So let us see if this works, graphing an intersection points with the way that we have defined. So I am going to, again, go here, up here, down, and equal to 1. So I'm going to find the point of intersection. And if you can see, I can still draw the point of intersection. So go to menu, go to geometry, points and lines, intersection points, identify the 2 graphs, and I have got the, got to skip here, and I've got the intersection point here. If you can read this here, right? But f of 1 is also negative 1.6, so I could have found out f of 1 as well. So the other way I could have done was I could have used my understanding of what it means to be an inverse and pressed enter, and it would have been negative 1.6. So either ways, it is just the same concept, but thinking backwards and forwards, forwards and backwards, right? Now let's go ahead. We are not done yet. All right. And now we have another function, which is g of x, and I'm going to define g of x here. And then this is an inequality. So let's see if it works for an inequality, So that might be a little bit interesting. So what I'm going to do is, just a moment. Yeah, I'm just getting this out of the way. Yeah. Okay. So what I'm going to do is I am going to define the function. Well, I have, defined the function here. So I'm just going to, steal Hassan's quick thinking here. And, I'm just going to define it and define this as, just hold on if I have done. Yeah. Okay. So this is the question, and I've defined g of x. And now the question here is solve for inverse, f of inverse of g of x. So what I'm going to do, I'm going to define this. I'm going to define this as h of x, the function, a new function. And I am going to kind of define it here. And I'm going to say, now f inverse is I. So I'm going to write this as I of g of x, because this is our composite function, right? And I'm going to define this. Okay. And now I'm going to graph that, because I have to find out where it is below.
So, ma'am, you can even define a composite function here. What would have been if we hadn't known this way? What would have been done?
Yeah. Yes, definitely. And now I go here and I can graph. So this is a graphical approach to the question that Jalaj had solved algebraically. You know, just arming yourself with all these skills is important, because this is a paper 2. And now I'm going to, this was, I think, wasn't it h of x? Was it? Yeah, it was h of x. So I'm going to kind of define my h of x. Okay. Enter. Okay, now if you see the graph here, it looks crowded. It looks crowded just because we are doing several things. I could have used another page, but you see the green graph. And if you see, this is 1. So it lies from 1 to its bound, its upper bound, which was pi by 2 plus 1. So I can even find the point of intersection, because we want to find where the function is below 1. So I can go in here and I can do analyze graph and find the point of intersection. Yeah, I can. So I have to click on the graph. So this graph, and hold on. There are too many graphs here. So what I'm going to do, stop. All right. Yeah, I'm just going to use geometry, because maybe that might be a little bit easier right now. And do intersection points. And I'm going to find both those graphs. Oops. Give me a moment, please. Just a little bit. Okay, so what I'm going to do, I'm going to go tab up, and just because there is so much clutter, I'm just going to kind of, hide these, the things that I really don't need. So it might be a little bit more useful, right? And I can also go up and kind of click this off. So it's like sketching all these on a new page, right? And now I can go here and I can do the intersection points. And I can click on this one, and I can click on I don't know why this is not happening, but it worked. It works. Let me try using analyze and intersection.
Ma'am, can you zoom box here and then try?
Okay. Yeah. So menu, geometry. Let me do points and lines. Let me control escape once again. Okay, so now. Okay, let me start again. And let me see if I can do geometry, try my luck again. Points and lines and intersection points. And this graph and this graph. This is strange. I had got it earlier and it had worked. I just want to make sure that, yeah. So if you can see this point of intersection, it's 1.78 and 1. So it works. I don't know what went wrong right now, but it is 1.7, 1.78 and 1. So the point being that graphically you can see that this intersection point is 1.78, and though the upper bound as defined by in the question is pi by 2 plus 1. So the bound is between the two. So this was the solution for that one. And I just want to show you the solution that involved, right? So solving it is between 1.78 and pi by 2 plus 1. Okay, all right. Any questions? I'm sorry for the that part not working, but it works. Right. So do we have any questions? Hassan, do you see any questions? We can unmute or we can.
Not now. If you have any question till now, you can ask.
Yeah.
Or we should be going ahead. Okay, ma'am. I think we should be continuing.
We should continue. All right. Okay. So what are I would like to ask the participants, what are your thoughts on this one? Do you think it is going to be a useful strategy? Do you think students will benefit from this in terms of communicating their understanding, or in terms of time efficiency? If their understanding about inverses is clear, graphical approach might really be productive and efficient. So I would like to know your thoughts on that one, and then we'll continue with a few more questions that we have.
I just wanted to point out something. My observation, this is a good method, and it is definitely very intriguing. Can you hear me, everyone?
Yeah.
Definitely for, the understanding, because it's built from the idea of the composite function. So definitely that's a very good strategy. My only thought, however, is that, we are talking about during the test mode. That means you're talking at the time of the exam. So when you use the word time efficiency, in thinking of time efficiency for a question that was, 2 points or something like that, that is something one needs to keep in mind, and it's open for discussion. See, don't get me wrong.
Yeah. Oh, no. Absolutely. We've got to kind of take the pros and the cons and see what's best for the students, right?
Also, here's another thing which this is something very personal, which I feel about the TI. In the TI, when we think about the options, how we define and how we use, and we use the word user-friendly, meaning we talk about things that come out naturally, come out very simply. The very fact, in order to draw an inverse function, that we have to use a certain route. Again, this is open to discussion. Please don't.
Please go ahead. It's a wonderful point. So you can yeah. It's up for debate. Yeah, please.
Because when we look at TI technology as something that is easily approachable and easy to understand, that technique is solid and superb. It only goes with kids who have that mature understanding of this is what a function is. I hope this is
true. And that is why we should insist that students use the calculator in every class. And this is not the first time they would be doing it. We would be doing it in class when you are graphing inverses, when you're teaching inverses. Yes. So point well taken, John. I understand. But look at the question. The whole entire question is 20 marks worth.
Yes.
The entire question is 20 marks worth. And every bit of question has been done graphically.
Yeah.
So yes, there are students who are not as savvy or not as comfortable, and I've seen many of the students who come from ICSE and other boards. They really, despite having the calculator, they would really like to, they feel satisfaction on algebraically solving it, and that's fine too. But here you've got to, when we're talking about different approaches students can take, I think this is one to consider.
Your point is well noted, and I think your point is more important. The point that you just made about that they should be encouraged to use the calculator, because I find in many schools the calculator is not is considered as a crutch. You know, I've heard many
Yes.
teachers say that, yo, Pehla, I want to teach them the understanding. I need to make sure that they have understood. As if that they, I want to emphasize on their thinking. As if to use the calculator, they don't have to use the thinking.
Yeah. In fact, there's a lot of creativity in here.
Absolutely.
Only good students can really understand what's happening. So here, this is an advantage for the students who really understand math well, and you know, are looking for a 6 or a 7.
Yeah.
So this is, you know, so definitely this is not everybody's cup of tea. Get that? But then we have students, you know, along the spectrum, and I think we can encourage students who are tech savvy to look at this method.
Like many teachers have said already, it is something that is it will definitely deepen their understanding.
Yeah.
And I will definitely, what Mrs. Nayak said, you know, I'm on page with her saying that use your calculator. In fact, the first things we must teach is whatever they've learned in their ICSE, if they're coming in from an ICSE or a national curriculum, that is, it'll only deepen the understanding if you go through a visual technique such as
yes, John, totally agree with you. But I have many teachers who speak to me, who they say exactly what you said, you know, no, we've got to place the foundation. We've got to really make the sound foundational grounding, and then we can move on to this one. But I think there's no harm in doing it parallelly, you know, in parallel.
Yeah.
And I think, yeah, right?
Yeah. Great job. Keep going.
Yeah, okay.
Ma'am, there are some chats you can.
Yeah, please, yeah. If we can kind of encourage people, because I think this is all about.
Ms. Yogita is saying yes, definitely clear visualization, but during regular classes, calculator are not on test mode. So do we have to encourage a student to check what are the options available and to press to test mode, or?
Yes.
My thinking would be, I think right at the beginning, this is just my thought. Okay, I'm open for correction, and I would say initially, because the prestigious is a restriction, right? Initially, when they've come in, allow for all the features, because we're talking about discovering. But when I mean, after some time, and that we need to decide for ourselves, like when we have when each group is different. So when we feel that they've come to a certain level and now they can switch to press-to-test mode, maybe the first assessments, formatives and other things that you do in your class allow for non-press-to-test mode. You know, eventually when they are getting comfortable, when the maturity is there, then try and tell, okay, now kids, you know, now these features will not be allowed. What do you think you should do? Is there another way to do it? So allow for them to also discover, because by that time they have gotten a bit more comfortable with the calculator. And I would say don't go with the press-to-test right away.
Yeah. That's see, the calculator is new. There are too many things to learn. I think we got to have a plan or a strategy to introducing to kind of interventions. You know, having these interventions, press to test mode, introduction. I think definitely there needs to be thought around it. Yeah. Oh, there's one thing so thank you, John, for kind of saying, yeah, you know, how do we weigh it against time and this, you know, how do we do that? So I just want to show you one thing where I found that, you know, look at the question here. Okay, I just want to point out the question. Okay, so it says this is a g of x function, and you've been given the domain, right? And all students are not, even in HL class, actually, I think it's a very straightforward concept of finding the range, right? Using the amplitude and using the vertical, you know, the principal axis and the vertical translation. So the -3 and the 2. So, but for students who really struggle with that, you know, it is just an idea. It is just a boost to their thinking or to their confidence. So if we go here, and I've graphed this as of g of x. So please, you know, excuse me for just going back to this question, but I thought maybe, you know, we could, I could just show you how we can build confidence. Yeah, here I was. Got too many things. Okay, all right. And then we are going back to this one, and I'm graphing g of x. Okay, g of x. because sometimes students really, you know, just looking at the enormity of that expression, they really shut themselves down at times. And when you graph this here, right, and then it becomes clear to them that, oh, okay, the range is from -1 to -5, though from the function itself good students would figure that out. But I think because the question does say, when you find the inverse algebraically, you state the domain, and this is where they can get stuck, you know. But if you look at the range of the original function, that gives them a confidence booster that what they got is kind of correct, right? So this is kind of, you know, I think you've got to train students to really use the calculator well, so their understanding gets better and better, deeper and deeper. Okay, I'm going on to move on to the next question, using the same kind of, you know, I had one more a teaching strategy. If we have time, I just want to show you that using geometry and using trace. If you know, if we have time, or we can do that some other time, how to draw sketch inverse. So when the first students understand functions and inverses, we can introduce that. But that can wait. All right. So I just wanted to show one more. So a few things that I have kind of chosen here. So this is another question. Just want to quickly go through the question and understand that it's a 15-mark question. My point here is introducing graphical approaches to efficiently solve the question. So algebraic solving has value of its own, but since this is paper 2, I think it is you know, important to look at this point as well. So now we have a function, we have a velocity function here, given here. It states, I'm going to quickly go through the question so that, you know, you kind of understand what needs to be done. The displacement of the particle at t = 0 is 3 meters. So we know that bit. Now you have to find the displacement of the particle when t = 4. So algebraically, what you would have to do is you would have to kind of integrate this function. So you get the displacement function and use the value of 0, 3 to find your c. So you get the cubic function. Since this is a quadratic function, the algebraic solution would be in that way, right? So I'm just moving ahead, and then we will address the question, and then, you know, we'll have a discussion about that. Now it says sketch a displacement time graph, right? So unless you have this, unless you have the displacement function here, you cannot really proceed further. So you sketch the displacement function, and then you have to find the greatest and the least value. So there are a couple of points for that displacement function. So ordinarily you would think, okay, you would integrate, grab the function and then sketch it. But let's see if we can do it in some other way without integrating the function algebraically. Then you have another function, which is, because if you notice, the first function is between 0 to 5, and then the particle has moves in a different manner, where the displacement is kind of defined as a trig function, and you've got to solve for values of a and b. And I want to show you how we can do that as well using the calculator. And then we want to find out when the particle returns to its starting point, which is 3 meters. Mind you, it's 3 meters. So this entire thing, if you've got a gist of what I'm saying, I will proceed to the question, right? Do I have any questions before we start? Like, is there anybody, missed out a part? Okay, so I'm just going to move on to that one. Okay, so what I'm going to do is first define this function here, b of x.
You said 3 meters. Where is this 3 meter? Is it given in the question?
Here. It says the displacement of the particle from
yes.
3 meters. Yeah. Thank you.
Yeah, but this will help us to find out the c after integration.
That's correct. Algebraically, it would, right? So that is what you would expect, right? So what I'm going to do is I'm going to open another. So this is a different problem. I'm going to open up a page, and this is going to be a calculator page because I'm going to define my function, and I'm going to write v of x. So v of x, okay, and I'm going to define it as, I believe it was 90 minus 3t squared, so it's a quadratic. So it is 9x minus.
And this calculator cannot take the t, right? Other letters apart from x.
It can. But for this question, I choose to write x because when you are graphing, the function is defined as f of x, right? So I'm just maintaining I'm being consistent with the variables, all right? And here it says it is from 0 to 5, if I'm not mistaken. It says from 0 to 5. So I'm going to kind of define this as 0 to 5. So 0 to 5. And I press enter. So this is done. Okay. Now let's go back to the question. Okay. Now you know the value of c after you integrate is going to be 3. Okay. Again, we can debate about some students not understanding that, but I think as you've gone far into solving and doing calculus for a couple of months, and after they've understood, I think if t is equal to 0 and if it is 3 meters, they would understand c, the value of c is equal to 3. All right. So I'm going to do this. I am going to write this as s of x s of x, and I'm going to define it as, okay, I'm going to define it as a function. So I'm going to go here and I'm going to take the integral here, and I'm going to go from 0 to x because it's a function. Okay, and this is v of x. V of x dx. Okay, and now I'm going to kind of done. So this is defined. Now let's look at the question again. So it says find the displacement when the t is equal to 4, right? So what I'm going to do is, since I know, I am just going to find out, since it is 3 already, it starts at 3, so I need to take the 3 into consideration, and I'm going to graph this from 0 to 4 because it says the first 4, if I'm not mistaken, it says when t is equal to 4. So this value is going to be equal to 4. And I'm going to write v of x, dx. So if you see here, right, it's already calculated. This 3 plus 4.
Ma'am, can't we just put S4 here rather than writing everything?
You could put S4. Yes, you could put S4, right? Okay. So
we have to give a colon after Sx or Vx.
Sorry?
That colon sign.
Ma'am, just show them how to do that. Sx.
Okay.
We have to give the colon sign, S of x, then you give it 2 dots. V of x, you give another 2 dots. Because we have equal, so do we have to give that?
Sorry, say that again, please. I didn't get that.
I'm saying the v of x and with s of x, after v of x, because we have written equal, so do we have to give it that colon sign, that double dot?
Probably he meant how this defining, when we define.
Yeah.
And
yeah, when you define, this is the notation for defining a function or defining a variable.
Okay.
Maybe I have not understood the question.
Okay, Mobin, when you define a function or a variable, you have to use this sign, which is
no, I know that there is such that, yes,
a
function such that. We say that this is a function such that this and this. But in the GDC, do we have to give that double dot on the calculator? That's what I mean.
Yeah, the symbol is right next to 9 with control T.
Here, this one.
Okay.
This one. Yeah. So if I do control this one, I get the sign, the notation for defining. Alternately, you could define in other ways as well. All right. But if needed, we can discuss this at the end. Okay. So this is another just way of understanding. Wait. So okay. Now the real thing is when you have to sketch this graph, right? When you have to sketch this graph from 0 to 5. So now, because this part is not difficult, integrating a quadratic function is no big deal. But the whole point was about the sketching the graph, right? So without having really integrating and found the function, if we can now open another page and graph it, okay, and you graph it, and now I'm going to write S of X okay, and here, if you see, I've got S of X.
John, इधर आना बेटा, वो तुम्हारा वो लेकर आना पाउच.
Sorry?
No, ma'am, just continue.
Okay, all right. Now, if you can't see, you can always change these values here. You know, I can just change these values, use tab and kind of now. So what was the function? The function said from 0 to 5. So I could have placed the 0 to 5 and clearly show where the curve meets the axes and the greatest and the least values. So I'm going to go here and I'm going to go to my function here and I'm going to place my restrictions here. And I'm going to say it is from 0 to 5. So this is 0 to 5. Five, and I press enter. All right, and now this gives me kind of you know, it gives me all the points. Like I can now go ahead and use trace again because I've got to do multiple things, and that is why I'm using trace. And I go back here and I get all these critical points here. So I get the 0, I press enter because it said both axes. I go up and then I can get the maximum here and I press enter and I go down. So I travel further, I get the 0 and I press enter and I go down here and I get, so here it is undefined. If you see, it is undefined. So I also wanted to show you how the trace function can show you that it is not defined beyond 5. So this point here, and you can always find S of, if you want to find that point, we can go back here and we can find S of 5. So what one of you had asked me to do. Okay, so I want to find the value of S of 5 and I press enter and it gives me negative 12.5. So I know all these values, minimum, maximum, and the minimum in the sense the point where it is restricted. All right, and now, so having done that and further question, all right, so we get this. Now this is one other thing which I find interesting. So now I've got to there is the displacement function of the particle beyond this one. So I'm going to kind of graph this. I'm going to kind of define this again here. A plus b cos 2 pi t by 5. And I'm going to call it displacement function. So I'm just going to go by displacement function, right? And again, this is a sign for defining here. And I'm going to write A plus b. And there are two variables. So let's see what we can do with it. Multiplied by, this is the cos function here. And, you know, my students like it when I call it action fraction. So it is 2 and pi by x multiplied by x over 5. And you'll see why I have defined it in just a minute. Okay, so this was the function. Again, it is important to note what mode it is in. It is in radian. If some of you didn't know, if you just click on this, it changes the mode from degree to radian. This is the new feature that has been introduced with the latest software update. and you are done with graphing it, with defining it. Now we have to find values of A and B, obviously, right? Now one value is when it is a displacement function. So when you go here, this point here, which is 5, negative 12.5, is one of the points for the linear function, and the other part of the information is given here. It says at times when S is 16.5 and T is 7.5. So what we can do here, use linear, solving linear or simultaneous equations. So I'm going to go to menu, I'm going to go to algebra, I'm going to solve systems of equations, and students can just, use, I'm just going to show you, because somebody had asked me if T, you can use different variables, you can. I am just, for the benefit of the students, use A and B, so there's no confusion, and I'm going to do okay. Now the first question part is, it is negative 12.5, if you know, because we just found out what S5 is, negative 12.5, okay, equals, equals A plus B multiplied by, now when you plug in 5, you are left with a cos 2 pi. So let's say the students don't know the value of cos 2 pi. So I'm just going to say cos 2 pi. Oops. Okay, cos of 2 pi. Yeah, and the other part is what information has been given here. Because at T equals 5, it is a common point between the two displacement functions. So this is 16.5 and T is 7.5. So I'm going to go here and I'm going to write 16.5 equals A plus B. You can just kind of copy this because I'm doing using the emulator, and this is 3 pi, or you can just have the students plug in T point, 7.5 if, okay, and I'm going to press enter, and I do get the values as 3 and negative 14.5. So this is just, I thought this was interesting for students to, you can solve using these kind of functions as well, right? Any thoughts on that one before we proceed?
Ma'am, could you also solve the simultaneous equation, after plotting it, then choosing option 4? That will give the intersection point by graphing it.
By using these both, but we don't know the values of A and B.
Okay.
Yeah. So this is because we have two variables. I thought it was interesting to see how you can find values of A and B. And now you can go back and place these values of A and B here. You can have these values of A and B here to solve. So we can, now I can say, okay, so instead of defining it here, I could have defined it right here. So there's no point in defining it there. And I could have said, now A value is 2, and this is negative 14.5. So I can do negative 14.5 because there's a further question to it. And I graph this. And now when I go in here and I can graph that function. So I've got to escape because I was in a trace function, and I can go to tab. And now I can go down and I can define this function. This is d of x, right? Press enter. So of course you have to say from t, because I haven't restricted the domain. So I can go back and I can write here is t greater than 5. So I'm going to write here such that x greater than, it is not greater than or equal to, because equal to has already been kind of used, and press enter. Okay, and you do get the equation, you do get the other function. And now the question is, what are the times when the particle returns to its starting point? So all you have to do is find the point of intersection between 3 So I can graph here, I can go to tab here and go to 3 because that was the starting, the particle was at the starting point, and I can find the 3 and I can find the points of intersection here. I can find the points of intersection here for this part here and for this part here, because it says from, right? It says from, yeah, 1, yeah, between 8 and here. So what you can do is I can find these points of intersection, the first graph and next with the next graph. Okay, yeah. So any thoughts? So since we've been looking at this only graphically, maybe you are a little bit, you find you you are still thinking about its value if you have been using or solving, or focusing on the algebraic method. But I invite you to kind of use both, and let the students decide what is kind of valuable to them, but also let them know this is a paper too. So the more technology comfortable they get, tech savvy or comfortable with the technology, I think it is going to be beneficial to them, right? Okay. So that was this question. I will let Hassan talk about inequalities. Before that, do we have any questions? Do we have any thoughts? Jalaj, what do you think?
This is brilliant. So I think it will be more effective if we use it often in our class.
Yeah.
And
definitely. I think when we solve questions, if we can just, and students are far more tech savvy than we give them credit for. They pick up strategies, they come up with ideas, they even provide some solutions. Oh, can we do this? Oh, can we do that? Oh, see what I found. I think it is just an opportunity for students to kind of explore and give them the time and the confidence to kind of investigate a bit, right? Yeah. So before I move ahead, I'd like to know if there are any questions about it, and I will share this. All resources are shared. So if at all you have questions or something which is not understood, then you can kind of let me know. Yeah. Okay. Hassan, do you want to show the inequality?
Yeah. Thank you, ma'am.
I think it is a huge benefit for linear programming, which is in AI, and for their math IAs, and many students usually, if they are economic students or chemistry students, they want to find that optimal time or the best opportune time. And I think what you are going to show next is going to be really rich. Okay. So over to you, Hassan.
Yeah, thank you, ma'am. Let me share.
Yeah, I'm going to stop share. And then we can do a couple more other questions later on if we have time.
Yeah.
Yeah, we will be sharing a recording.
We will be providing the recording. No issues on that.
Definitely.
So let me move ahead with the presentation, and let me show you, before going to the inequalities and all, let me show you one more possibility of using NSOLVE. Okay, so if I am on a graph page and if I do some kind of relation graphing, let's say I wanted to find the graph of x squared plus, let's say I'm making it randomly, okay, equals sine y. It doesn't give me this.
The screen is very hazy. It cannot be seen properly. It's very hazy.
So is it hazy?
It's a little light. It's a little light. The screen which yeah.
Can you see this properly?
Yes.
Okay, no issues. What I did is I entered a relation here which says x squared plus sine x equals to sine y. I randomly made it, and if I hit enter, it doesn't give me anything, but it says relation input not supported. Okay, so it's a implicit kind of function where I do not get the graph of it. But if I extend the possibility of NSOLVE and try to figure out what NSOLVE basically gives us, if some of you, if you are using CAS version of the calculator, if you are using a CAS version of the calculator, you can see many other options there that can solve it algebraically. So from there, you can get the possibility of what NSolve exactly doing. So let me just store this as
Hassan, you're really empowering the NSolve, huh?
Yeah, because it has more capabilities that we haven't yet explored.
Yes, yes, definitely.
So if we go to algebra and we see NSolve is not only used to just solve for the values, but it is something else. So if I do something like this, if I say like this is my equation and I want a result of values for y, okay, for y. So if I hit enter, it says done. Okay, what is, if you have CAS model, I recommend you, John is there, I think John also recommend CAS version of the calculator. If you use CAS version of the calculator, all of you are teachers, you should have both the CAS and the non-CAS software in your laptops or computer. You go there, you solve this function just for this value. Okay, it won't give result here, it won't give result here, but if you use this in a CAS, it should give you an expression in terms of x for the value of y.
Hassan, can you is it possible to show that?
Okay, if you insist, let me just put my calculator out of test mode and let me show you what the result we will get here. Okay, just give me a moment. So I'm exiting from PES to test mode. So there's an option. Okay, while my calculator is restarting, can anyone like John, can you tell what would be the result if we solve this with the CAS version of the calculator, or anyone?
I'm only looking for this exploration because my question is in the press to test mode. So when you're telling me about CAS, that is not allowed in the press to test mode. So
definitely,
I'm here as a learner with an open mind. So I want to know only about these things because we're talking about a press to test mode. So the idea of CAS should not be encouraged right now.
Yeah, but I just wanted to show like the result you will get if you solve. So it will give you one idea like what would be the result. Okay, so if you can see my handheld, I'm not in a press to test mode, and this is my CAS calculator. So if I go to menu, you will see in algebra there are many options which are not available in the usual mode. So if I say only solve, and if I write this, let's say x squared plus sin x equals, I don't know whether I'll get the result or not, but let us try. And in the terms of y, so I'll get a result. You can see I'll get an equation, whole lot of equation in terms of with respect to x, and it will give me the y equals to whole equation. So if you go back to your non-CAS version of the calculator, so here what NSolve is doing, NSolve is solving for all the values of x. NSolve is doing what numerical solve. NSolve means numerical solve. It will solve for minus infinity to plus infinity for all the values of x. It will solve and it will give you one a list, and for that list it will create a graph. So this is what NSolve is doing. If you have this deep idea what NSolve is doing, you can do a lot of things with NSolve. So what I did is I stored a function now in only x, which is equals to y. And now if I go back to my calculator or a graph, and by the way, you can do this in a press to test mode. Okay, if I go back, okay, now I don't have to go to relation because I have defined a function fx. Does it give? Yeah, you can see you will get some kind of result, whatever value for n is solved, the NSolve is solving. So by doing this, you can solve, like if I change something, like say if I put x here, if I put y here, it's an implicit function. Let me store it, and if I see, should give me the result. Okay, so like that you can even use this and solve to draw some kind of implicit function as well. Okay, so you can use it for any function. Okay, so this is it for the implicit function. Let us go and check what we can do to draw an inequality, and that too if I show you, that too x greater than or x lesser than kind of inequality, where you do not have any y variable available. Okay, so if you are not in a press to test mode, you can do it very easily. So let me just go and show you how you can do in a normal mode. Okay, so what I'll do, let's say I have few of inequalities available for us. Let's say x plus y equals 2. It will draw the curve for you, graph for you. If I do something like x lesser than equal to 6, it will draw. Okay, it will show you. But as soon as you go into a press to test mode, so let me just go back to my calculator and put it into press to test mode. So if anybody wants to see how I'm doing that, you have to, yeah, so this is my calculator. So what you need to do, you need to switch off your calculator first, switch off the calculator and hold down escape and on key simultaneously. Okay, it will take you to the press to test mode. So under a press to test mode, what you need to do, you need to uncheck numerical solve, then go down, yeah, then this, then you have to uncheck this option, then you have to uncheck this option, last 4 option you have to uncheck, and then you have to uncheck inequality graphing as well. Okay, you have to uncheck this inequality, but you won't be able to draw inequality of where y variable is not available. Okay, so that we will see. It won't give you the straightforward answer what kind of inequality you can do or which kind of inequality you cannot do in a press to test mode. It doesn't give you the answer. We have to check. So let me just put my calculator in the press to test mode. So now it's going under the press to test mode. Let's say if you don't have any y term, okay, if you don't have any y variable in a inequality, what you can do, if I do something like this, let's say I do not have any y term and I want to draw a inequality x greater than 3, x greater than 3, can I do like this, 0 times y greater than 3 minus x?
So you've rearranged, you have transposed.
I did a transposition, and what I did for y, I put a coefficient as 0 because this should be true for all the values of y. So what I did is I put the coefficient of y as 0. So because my calculator is going into press to test mode, let us see, can we do this? Yes or no? Can we do this?
I think so.
It should be true. If I hit enter, it should be true. Yes. It is nothing but x greater than 3. Okay, it is nothing but x greater than 3. So this we can do if we do not have any x term or a y term. Okay, so let me go back to my calculator and try to summarize what I'm saying is, let's say you are in a test mode, you have given some inequalities, you'll go to graph, if you press delete, you can see there are 6 options. Okay, there are 6 options available under a exam mode or a normal mode as well. But if you try to go to the 6th option, that is relation, and if you try to put x plus y and let's say greater than 3, it doesn't give you the result. Okay, it doesn't give you the inequality graph. So to manipulate this and to draw the inequality graph, what we need to do, we need to create an inequality that is
in the Y form?
In the Y form.
Okay.
Exactly. So if you go back and if you go to graph edit, entry and edit, and if you go to function and if you press delete, you can see the top 5 options. Okay, you can see the top 5 options. Now these top 5 options will work.
They will all work in press to test mode.
They will all work in a press to test mode.
So Hassan, if there is a Y term, you got to isolate the Y and then graph, so you get the graphing.
Exactly.
Right?
Exactly.
Yeah.
So
okay.
what I will do, I'll select, okay, let's say Y, I have solved the inequality. I have isolated Y and I'll put X plus, let's say, I'll do 3 minus, let's say 2X. Okay. Now if I hit enter, it will show me the graph. Okay. So I have to isolate the Y term and the X term using the transposition here. Okay.
Will it show points of intersection? I'm talking in terms of linear programming.
Okay, let us do that also. Now if I draw another graph, let's say Y greater than, because Y is isolated, greater than 3, and let me just move it a bit down. Okay, greater than equal to 4. Yeah. So let me just find the intersection point. Okay, so point was the intersection point. So let me just go to analyze graph. Let me go to intersection and try to find the intersection point. Yeah, it is giving me the intersection point.
Brilliant.
We can use intersection point, or we can even use the intersection points feature, which is given under the geometry mode. So I'm so sorry. So to use the inequality, we have to isolate Y and X using the transposition first, and then we have to put into the calculator. Now let me go to the normal mode, and here we drew this graph. Let me try to draw 2 times Y greater than 3 minus X. Can it be done? Yes, it can be done, but as soon as you go into press to test mode, and if you try to do that, okay, you try to do something like this, 2Y greater than equal to 4, and if you press enter, it won't allow you to draw. So you have to completely isolate Y. Yeah.
So basically it has got to be in the Y form. Exactly. The coefficient has got to be equal to 1. Is that what that's what it means?
Yes. So coefficient of Y should be 1. Okay. So if I transpose this as well, and if I divide this by 2, in that case I can be able to draw. Okay. Now let me take it further and let me add a new graph page, and let us try to do some relation which says X greater than 2. It won't allow. Okay. It won't allow. So I can see I do not have any Y terms. So why not what we have done?
The 0 times Y thing, Hassan?
Yep. What we have done in our normal mode, 0 times Y greater than 3 minus X. Let us try to do in a press to test mode. Okay. And let us see, can we able to draw or not. So we will transpose this and we will say 0 times Y is greater than 2 minus X. Okay. I'll hit enter. It again says restriction. Okay. Why? Because Y coefficient should be 1.
That's
the coefficient of Y should be 1 under a press to test mode. So if I just take this 0 and put it on the right hand side, if I transpose this 0 as well, okay, 0, can I be able to draw? Invalid input.
And anyway it's undefined, right?
Anyway it's undefined. What if I say, okay, let it be approaching to 0. Hit enter, it gives you the graph.
Interesting.
To check, let me just quickly draw Y greater than equals to 2. Okay, and let me just make this as equal to, greater than equal to. and try to find, let me try to find the intersection point, whether it is giving me the correct answer or not. Okay, then only we can say like this is an approximation, but whether it is giving me the correct result or not, that we need to check. So if I go to analyze graph, if I go to intersection, and if I try to find the intersection, whether it is giving me the correct or not, yes, it is giving me the correct answer. So by using the transposition method, isolating y and giving the denominator as approximately 0, you can be able to draw a vertical line as well. So now if you have got any linear programming question where x is there, you can do it like this.
This is good. My comment again, Mrs. Naik, will be, see, this is good for people who know. He's going into the theory and whether it's transposition. My opinion, whether it was for the inverses, that method that he spoke about, or this method, it defeats the simplicity. The simplicity that TI stands for. You're talking about a user-friendly nature, the simplicity. This, someone really needs to, who knows the concept of it. This is good. I'm not against the fact that whether it can do or not do. But
John, that's correct. You are absolutely right. This is not for the average student.
It is not.
It is not for the average student, but it doesn't mean that we cannot.
I agree.
Reach out to the students who are on the exceeding, who are on the farther bit, right? And this comes with the algebraic understanding of the math behind it.
Ma'am,
Absolutely right.
I'm not saying whether it can be done. See, because see, the thing is not about, at the end of the day, it's not about whether TI can do or cannot do. That's not the question. The question is staying true to the nature. If you're saying TI is something that is accessible to all, that is user friendly, the very nature that everything is, menu driven, when everything is so simple, in order to find the function, can it do an inverse function? Yes, it can do. That's not the question. The question is to approach that. How many steps are we going? How many are we stretching?
But John, if you read the title today, it was getting creative with the TI Inspire. So we do not disregard what you are saying, because there is absolute great value in your thinking, because that is an average student, and we have average students in our class who got to make these concepts and the use of TI accessible. But today was, what if students wanted to use it on their on their exploration of what if students, it meant students who had to weigh in on the time and the accessibility of the calculator. So
likewise, with full regard to all the creative approaches that you've said and brought about, again, I'll say the same thing what I said earlier. In a press to test mode, you're talking about an examination time where there is a time constraint. That time, yes, I'm not saying we should not be creative, and I totally agree that you're saying this is that the topic of the webinar that you've chosen is about the creative aspect of how about it. But at the same time, we need to understand this is in an examination time. Students in examination time, whether they are brilliant, not just the average kid, they are always stressed. I find sometimes some of my own kids who are the most brilliant kids in the class are often more stressed because at the time of the exam, there's something called a time that they constantly struggle with. Within a given frame of time, on a normal day, they would have thought of something very easily. But just because they were in the exam setting, they would have normally got, because of the time factor, they're not even able to think straight.
Yes, John.
In that condition, I'm thinking in that condition, in that state of mind, how much will someone push themselves to think like this?
No, but this is not on the day of the exam. This is in your regular classes. That's what we are encouraging. We are inviting you to use these methods in class.
Ma'am, that is okay. That is okay. But the thing is that if it's a press to test mode, we're talking of an exam time, no? Why will you want to do that for an exam in a non-exam setting?
True. So definitely this is not everyone's cup of tea, as I said earlier. These are some of the
but full marks to creativity, man. Full marks to creativity.
And,
oh, thank you.
And I'll take this as like a part of differentiated teaching. And with these creativities, we can reinforce the understanding of concepts in the student, like understanding of inverse function. It can go like beyond what they usually do. and out here for the inequalities. So it is like part of differentiation. We do differentiation for
Agreed.
at all the levels. So it's a brilliant thing. Thank you so much.
And we are open to
Suggestions, obviously.
suggestions. Participant can also speak
Yes,
about.
please. Can we hear from the participants, please?
Can I make a statement, Hassan?
Yeah, definitely. So
Yeah, personally, I see it a little differently. I feel that sometimes in the class also, we might want to keep in the press to test mode, not in an examination setting. So, so I think there could be a creativity side, I think, where we can keep it off press to test. And I see what is discussed today, because sometimes you don't need to take a lot of multiple problems. One problem itself can generate so many fantastic ideas which can be repeated. So I felt that it's something worth exploring and keeping as a discussion in the classroom. That's my takeaway today.
Yeah. Any more? We've got several people, here, and we would like to see John's
yes, Greta.
argument. John's point of discussion is valid. That is what majority of teachers would think. He's not taking, that may not necessarily be his stance, but that is what he's saying. What comes to an average, is what comes to mind when you first look at these creative methods. Why, when there is something simpler, right? He correctly said, he said it defeats the purpose. But then, there is value to it if you look at for some students who really look for the challenge, who really want to test, exploring the TI or understanding math doing differently, and it could be for those students. So please,
yeah, I think I agree with you, because my students are more exploring and they are more risk taker than me, because I just do what it seems to be like, best way, but my students sometimes come up with very silly ideas and very something that I didn't try, right? So let them explore, and it is good to know what restrictions are in
absolutely
the test mode. So once we let them know these are the restrictions in test mode, so in the given time limit, I don't recommend you to do this. Like, definitely, drawing by hand with those system inequality is much faster than drawing with TI-inspired calculator. And they know, but kids, they love to work with technology. They are different from us. So let them explore, but at the same time, we give them instruction. Hey, by the way, you should know, you should change that y is less than or greater than when you use in PPT mode. So that's it, right? So it is very useful. I am very thankful that you brought this, right? And
so Marie, you have a great point, because when do we introduce the press to test mode in class?
We don't, because let me tell you what happened. I usually do that only for the semester exam and also mock exam only. So that will be only twice a year, right? And usually what I found, students, they don't even know how to unlock their TI-inspired calculator. They usually bring their blinking calculator to me. Miss Marie, can you unlock my calculator? I have this pop-up message all the time. Then I do unlock, right? So, they don't know how to handle this PPT mode and unlock it and things like that, right? So I think it is good that the more we practice, right, they will be familiar what is possible, what is not possible in the exam, actual exam.
Yeah, right.
So it's good practice. It's good practice.
Yeah.
Greta?
Yeah, hi, Ms. Naik. I just wanted to add that I'm one teacher who, uses press to test mode quite often in the class, unlike many. This is just to students have the habit of saying, oh, miss, but my calculator was in that setting and then I got stuck. So I think over the years, we kind of brush through the skills and ensure that students know how to set a calculator in press to test mode correctly. so that they're not completely teacher dependent and the teacher can just go and check in later. So, at least one class a week or some questions while we are in problem solving. I think putting the calculator into press to test mode certainly helps.
Definitely.
And also I think inequalities, the concept that you explained, as somebody else was also saying, was very useful for other concepts like Voronoi and other building on other concepts. So it's a good base, I would say.
Yeah.
Thanks.
Linear programming as well. Yeah. Agreed. So I think we've got to kind of, when we start the new academic year, some new resolutions. I think, press to test mode, using it more often is what I'd really take away that point, So that was one thing. And I just Hassan, do you want to talk about from the question point of view? Visually how it would look?
I do have one question, but I think they can let me show.
Yeah.
The question, yeah. I do have one question, like there was a inequality given where both sides you have the relation function, and here they want to find the domain. So here I have used a similar kind of concept where I have transposed it and I have divided it by approximately 0, and I have got this fantastic inequality graph where I can find the intersection point, and I can say like these are the limits under which visually student can see. I don't say like you use this, but it will be more visually appealing, like they can see and they can find like, yes, the function is coming somewhat here. Yes, you can use the graph feature of the calculator to solve this, but this is also one of the ways to do.
And by transposing, you mean you turn it into a linear inequality?
No, you can just take the left hand side to right hand side. That's it.
Okay, and then should we try this?
Yeah, let us try. Let us try in the press to test mode only.
Yeah.
Okay, so I have given one equation here. What happened? Wait, something happened. Oops. Wait. Okay, so I'll do in the normal mode only. The same step will go into press to test mode. Okay?
Yeah, no worries.
Okay, so what I'll do, I'll just go to my relation. Can you see my screen?
No, not yet.
Okay, so let me just share. Okay, so this is my calculator screen.
Yeah.
And this was a question: x minus 2 over x minus 3 lesser and equal to 1 over x plus 3. So okay, so let me just draw this. So what I'll do, I'll say, okay, so first I'll just go by y lesser than or equal to. What I did is I transposed it. Okay, so at first glance, I transposed it. Okay, I took LHS to RHS at first glance. Okay, I'll say 1 over 1. Let me just put a fraction template. 1 over x plus 3. X plus 3 minus fraction, and the equation was x minus 2 over x minus 3. X minus 2 over, oops. Oops, I lost it. Okay. Lesser than or equal to 1 over x plus 3. Again, something. X plus 3. I'll go here. I'll say minus. I'll put a fraction again. X minus 2 over x minus 3. Okay, I can draw the graph of this. It will look something like this, but there wasn't any y term. So what I'll do, I'll make a bracket here. I'll make a bracket and I'll divide it by approximately 0. Okay, I'll divide it by approximately 0. Hit enter, it should give me this something like this. And then I can find the intersection points, like I can find the zeros, and I can do the same thing again. So it will look somewhat visually appealing to me. That is why I found
definitely. And it kind of, if we superimpose that image on this image or put it side by side, it kind of reinforces the concept for the student.
Exactly. So if I draw this, you can visually see like, yes, what you have done is the correct thing.
Yeah. So definitely a visual treat.
Yeah.
And sometimes, there's for communication, for the internal exploration, there is great emphasis on communication, right? Different forms. And I think this is how students can really demonstrate their understanding of mathematics. And this tool can be used to kind of enhance that.
Definitely. Yeah. And we can see like asymptotes are also be visible here. Like x equals to 3 and minus 3. And we can.
Would the trace function work here, Hassan? Do you want to show let's see if the trace function, because sometimes when there is no, it gives you a dotted line. And I was just wondering if it gives a dotted line here in this case or not. So it gives, okay.
It is giving 0. Then you can go to the left side and you can find the 0 here as well, like 1.73. It does give you the trace option to trace the inequality.
Yeah.
Hassan, I have a can you go back to your calculator?
Wait, yeah.
Okay, can you show me the question once?
Oh, okay.
Go back to the earlier page.
From the slide, from PowerPoint.
Yeah, PowerPoint.
Okay. Can't we do this directly, like just draw the graph of, take everything to the one side, draw the graph, mark the point of intersection?
Definitely.
If you're looking at less than 0, just to look at the graph below the x-axis.
Exactly.
But that's what it did. That's what it did, Jalaj, in the beginning. The rational function that is drawn, isn't that what it is, Jalaj?
Yep.
Yeah. So that's what, and if you see here, that's I think when you superimpose both images, it makes it more clearer.
No, what I mean is, like, why should we divide by something that is close to 0? So I think this makes it unnecessarily complicated. Like, it's in my opinion.
Because you cannot. So his point was, when you can't do it in the press to test mode, this is how you can graph. So this is not for this particular equation. This was just an example. This was just an example. In case you cannot graph inequalities in which have got just which have got a combination, the x terms, then this was a strategy to combat that. So this is not the right. I don't think this is an illustrative example to show. This is just an example to show that this is also possible.
Correct.
Yeah, I could not find. I was going through the IB questions to look at which would make more sense. But as John pointed out, if simplicity, if you can do something simply, why do you want to complicate matters? So given that front, I think it made some things simpler, some things are better simple. But his strategy is when you have everything in the x terms and you cannot graph it in the y form, and that's what he explained that.
Okay, but still I feel like if we just use in the graph mode, which is available in PTT, so just sketch the graph and decide on the region according to the sign of inequality, and
below the axis and above the axis.
Yes, definitely we can do that.
Yeah.
That makes sense also.
That makes sense. Also.
But this is
one of
the options, but this is not for a particular question. Like you can.
Yeah. Great. Yeah.
Maybe
Thanks.
it makes more sense for Voronoi diagrams or for linear programming. It might have more value in those cases.
Mm-hmm.
Yeah.
I agree.
Yeah.
Thanks.
Thank you. And thank you, Shada ma'am, for the wonderful support and the session. And yes, thank you all the participants. I hope you like the session. Please do give the feedback when I share the feedback form with you, and we will share the recording with you as well. So in the last, if you want to speak, you want to say something, you can speak and you can say. Or do you have any question? Yep. Thank you. Yeah, somebody has raised hand. I don't know. Yeah, Mr. Mubin, if you want to say something.
Yes, this question is to all of you, Mr. Jalaj and ma'am, and Mr. Hassan as well. I mean, because I'm talking from my experience teaching mathematics application and interpretation SL. This year, two of my students achieved 6 in the math AI. Now I'm wondering, they took the non-exam route, not the exam route, and they completed the IA and they did very well in the mock exam. Now I'm just wondering what could have been done from me or from the student that could achieve them 7 actually, or is it not possible to get 7? I mean, how does it work? I mean, I've been teaching, math, AI, and A. This is a new syllabus from this year, but these students did very well, but they did not manage a 7. They achieved a 6. My question is, as mathematicians or as educator, what would you advise or suggest me that can give students a scope to get a 7 out of 7? Or is it, I suppose, not impossible? It's a general question, not necessarily directly linked to this session, but it is about the AI actually.
Yeah, Mubin,
what did you predict? What was your prediction for your students? What did you give them as predicted grades?
Predicted grade, I gave 6, they got 6. Another student I gave predicted 6, he got 6. Another student I predicted 5, he got a 5. Now, so
okay, this year in the
I want the suggestion from you that that's right, non-exam route, right?
So in the non-exam route, it is different. So what method they used in non-exam route this year was they looked at your prediction. So let's say you gave a 6. So if 6 ranges from A to B, your grade boundary is, let's say, from A to B. So they will pick B from your grade boundary plus in the exploration, whatever they get. So 20% means the entire exploration marks plus 80% of B. And together, if they fall into 6 or a 7, they get 6 or 7. So this was the process they used this year. So if you get 6, then there is a high chance that they will get 6. And if you give a 7, there is a high chance that they'll get a 7. But
that means if I would have predicted 7, they would have got 7.
They might have got 7. Also, it depends on the exploration. If the exploration is very strong, and after moderation, if the exploration is into a high band, then sometimes 6 becomes 7.
But Mubin, I think, did you not predict them 6 for a reason? Because you thought they would perform in the band of 6. That is why you predicted a 6 would be my thoughts. And very few students, it's just 15% of the students get a 7 in HL math. So I think that is the challenge there as well. But 7 doesn't come in easy.
Okay.
This time there was a certain number of 7s and 6s we could give in, right?
Yeah, but you could have challenged that.
Right. Right. So, I mean, if Mr. Bhuban had challenged it or not is another question.
Yes. Yeah, you're right. Maybe he didn't like his IB coordinator must have asked him, okay, you need to give 2 6s or Mobin, was there any instruction from your IB coordinator about the allocation of grades?
Oh, she said that be honest with the grade.
We can't hear
what
you.
Do you think they?
Sorry, you aren't clear.
Oh, I thought
They can.
Mobin, we can't hear you.
You can sign it. Don't over predict or don't lower it. You just put your profession. Hello, can you hear me now? Hello.
Yes.
Hello, can you hear me now?
Yes.
Hello, can you hear? Hello, can you hear me, Mr. Jalaj?
Yeah. Go ahead.
Hello. Right. Yeah, my DPC said that you just predict whatever you professionally think that they deserve it. Okay, don't over predict or don't lower it. So I gave them assigned the marks as based on their IA and based on performance in the class, based on their mock exam. So what I want to know that what was there any significant difference between getting 6 or 7? What I'm saying, had I predicted 7, they would have achieved it.
Hello? But they took the non-exam mode, right?
Right, ma'am.
Yeah, but then as Jalaj pointed out, if they are the IA, you marked a 6, and if they are, you had predicted a 7, I think that should really reflect in their class performance throughout the 2 years, right? So
Shraddha, I think there are cases where I think even if the IA was like, let's say, marked a 4 and the student was predicted a 4, there are cases where students have gotten a 5.
Yeah, I'm aware. Yeah.
So in this case, if the IA had really stood out, even though the prediction was a 6, it should have gotten a 7 then.
Exactly, for a strong IS, because see, if we predict a 6 and 6 ranges from A to B, so they take 80% of B, that is the higher limit of the higher mark of the band. Plus, if the IA is strong and if it gets moderated to a better band, like I think Mobin's is talking about MAISL. So I think 18, 19, 20 was 7.
Yeah.
So if it is moderated to 18 or 19, then if the total marks in 7, there are many students who got upgraded, I would say, to 7, to the next band. It happens, but it has to have a strong, very strong IA.
Yeah. I think the IA, I think it all hinges on the IA,
Exactly.
Yeah. Okay, it's almost 5 o'clock. So, thank you for joining us.
Yes, ma'am. Thank you.
And yeah.